Hey everyone, this is Peter Estes of Valley CAD, and it's another Just a Thought Thursdays. In today's video, what I'm actually going to show you is some designing processes and how I went about a conceptual design for one of our clients. And actually, I was designing this live on Twitch, and as I was designing, I was explaining each feature I was doing and testing out different apparatuses and so forth, or features within SOLIDWORks. And so if you're not familiar with Twitch, I would highly recommend go check out Twitch. Just simply Google twitch.tv, I want to say, or twitch.com, and then on there type in @ValleyCAD. With that, you'll see our Twitch channel, and you can actually see me designing this this component, or this end cap, on a step-by-step process. So pretty fun to do that. Love going on Twitch. While we're on there, you can also ask questions and so forth. It's a great platform, actually. So highly encourage you, head over to Twitch, look for @ValleyCAD, all one word, and subscribe to our channel. That way you know, hey, when we're streaming again, you can simply get notified on it, and you can watch us live and ask us questions and so forth. So all right, so let's hop on over to SOLIDWORKS and let's look at this. So as I was stating, I designed this live on Twitch. And so I wanted to kind of come back on here and do a YouTube video on it, showing just a step-by-step process on how I went about it, and kind of giving some design techniques on how I did it and the reasons why I did it. So starting off, 2 days ago, I met with my client, High Sierra Showerheads, and these were some of the notes that I took down for this end cap. If you're not familiar with an end cap, what it is, it's a display at stores. And so you know how you got aisles and so forth, and at the end of each aisle there's sometimes products that are displayed there. That is considered an end cap. And so my client, High Sierra Showerheads, is actually who it's for. He's starting to move his products into brick and mortar stores, and so with that, he was saying, hey, I want to try to make an end cap. And so I was saying, well, we could design that for you, and also we can make it for you. So he's given us an opportunity to try that out, and super stoked and excited about it. So this is our first design of this, and the requirements that I was told was that it has to be 34 inches wide, 13 inches deep, and between 18 and 24 inches tall. So let's check it out. Here's how I went about my beginning process. I started off and did a simple surface plane on my top plane, and I drew it off at being at 34 inches by 13 inches. And this is kind of my parameter saying, hey, this is how much real estate I have to work in. From there, I went in and I made planes. I made a plane 1 and then a plane 2. I'm going to turn them on just for a little bit so you can see what I'm talking about. So this is my surface body right here, and my surface body is saying the parameters of what to work in, and I simply did offsets, and I told it to be coincident to each edge based off my right plane. So I'm trying to keep my origin and all my planes centered about my part. And as we start looking at a couple features from now, you'll see why. So the very next thing that I did was I came in and I extruded this body. And so if we look at my sketch that I have here, I gave a couple different options of how we can display his product. And he really wanted, the owner of High Sierra Showerheads really liked this one. Because what we're planning to do is make it to where this angled face here is actually going to be where the company logo goes, and we put the shower heads across this vertical face. So that is why we came up with this little design. I kind of call it the shoe design. And so simply here, sorry, excuse me, what we did here is we did boss extrude 1, and then I did a fillet on this inside corner. I did this fillet actually after the fact. I started applying some other features, and I go, oh shoot, I need to apply fillet here, so that's why I did that. So after I did that, I did a simple mirror, and I used my right plane to mirror this body over to the other side. And then from there, I was looking at manufacturing processes. How is this thing going to be made? And so ultimately this thing is going to be made out of plastic, and so I applied ABS plastic on it. If we use some other plastic, that's fine. It's all 1/8 inch thick as well. And so what I was thinking was that, well, I could utilize the plastic manufacturer to say, hey, take a sheet and I want you to heat up a certain distance in and just bend it and I made it to where this is going to come in at 30 degrees. Well, it says 120 there, but it's a 30-degree angle based off of my existing sketch 3 there. And so part of my technique here of designing this is I wanted to make it to where, hey, if I made any changes on here, such as like that 30 degrees gets changed, I want to make it so everything else will update as well. So by me doing that, what I actually utilized was I did that mirror function. So I mirrored this body to the other side. So if I make any changes to my first body, it's going to update this one. But then if I make any changes to this, to my first body in that shape, it will also update this little sheet metal part that I use as well, or body I should say. And how does it do that? Well, what I did was I did convert entities on here. So I selected this edge and this edge and said convert entities on it. And convert entities is a phenomenal tool. You'll probably hear me say this multiple times. I always say the term, let SOLIDWORKS model for you, don't model for SOLIDWORKS. And here's a perfect example of that. By me coming in, and if I drew this line and then drew that line and gave it dimensions and stuff like that, I'm giving it a whole new set of rules. But in reality, I want this line to always go the distance of this edge. And I really want this line to always go the distance of that edge. It's just what I always wanted to do. So instead of me coming in and trying to put dimensions on it and so forth, if I made any changes to this body here, I would then have to go into this sketch and make those same changes. The more dimensions that you put into SOLIDWORKS, the more likely you are to forget one of them. And so I try to make it to where SOLIDWORKS is modeling itself. I already came in and I gave this first body rules. So why would I want to come in and give a whole nother set of rules into another feature that's going to be dependent on another feature, right? So here's this in testing. So if I took this and I said, all right, from the very beginning, let's say I change my parameters of saying this 13 inches is going to be now 16 inches, and I want to make this 34 to 24. Well, once I push Control Q, let's see what happens here. It all shortens, but also this grew. Now, why did that happen? Well, remember, I made it to where my origin was centered about my part, and I used my right plane to mirror this body onto the other one. So my plane's always dead center. Now, I also made it to where my plane 1 is coincident to the edge of this surface body that I have. And so that means if I make any changes to my surface body, it's going to update everything else. And also if I look at my Boss Extrude 1 and I edit that sketch, we'll see that I made 3 rules in here. Well, actually there's more of that, but 3 dimensional rules. And that's saying, okay, I want my overall height to be 18 inches. That's part of my design intent. And then I just made this back edge 5 inches, and I just said make this 30 degrees. Now let's say I came in here and I said make that 45 degrees. And let's say I want to make this so it's not 5 inches, let's make it so that's 7 inches. And I say okay to this. You'll see that it's going to update this body. And it also updated this body, because I made these 2 other bodies dependent on this first body, depending on how I sketched it, and applied relations between them. Pretty cool, right? That's kind of what I wanted this Just a Thought Thursdays was about, was utilizing SOLIDWORKS to model for you. Now, simply coming back into sketch 1, let's bump this back to its original sizes of 13 and 34. Simply push Control Q, updates, and it's done. I don't have to come in here and say, oh yeah, I need to extend that out a certain distance or update plane 2. You don't have to do any of that. Technically, I don't need plane 2 at all because I mirrored the body. If I decide to use plane 2 and do convert entities of this body onto that plane, that's when it's used. But I still kept it there anyways. Okay, so moving along, the next feature that I applied was another Boss Extrude. And I did it on top, and it's another 1/8 inch piece of plastic. So that way this thing looks fully enclosed. As you push it up against the end of the end cap, it looks really good. And by the way, I'm talking about this end cap. I kind of explained it. This is an example of an end cap. So where you see these light bulbs is actually where the this new display rack is gonna go. And it's meant for True Value stores. That's a local hardware store here in California, Central California actually. And so we want to make it to where it'll fit on this shelf here. And then he wants to make it so each of the shower heads for High Sierra shower heads is packaged down below. That way someone sees it, go, man, this thing is phenomenal. They could buy it right there. Pretty cool. All right, so now we take this and so I want to make it to where this will push up all the way to the back. As we have inner working components will be hidden and so forth. Okay, next up, what I did was I did sketch 11. And sketch 11 is based off of what I did for here and here. And I just did a simple rectangle and I made it coincident from here and to the inside edge here. Once again, if I make any changes to my surface plane 1, it's going to update all this automatically. So I use sketch 11 to come in and give me a 2x2 wood frame structure. That way I can make this a little more rigid and so forth. And it should do the job. I might come in and put some wood cleats on the bottom that will run the distance of this. We'll see as we move forward. Once again, this was just a preliminary design. Then after that, I did some cutouts. Now these cutouts are meant for where the shower heads are going to be mounted onto this display rack. And it's going to, after I did that, I did another sketch. And I wanted to make it to where my shower heads will be equally spaced on this display rack. And made it to where there will be 5 actually. And so I got this hole here. And then I did a new sketch, and this sketch is utilizing a tool called Segment. And what Segment does is, if you have like a line here, I know it's a little hard to see, but that line, I simply select it and select the Segment tool, and I specified I want to have 3 dots on here. And what's so cool about this is after I do that, I could come in and do what's known as a sketch-driven pattern. And what SOLIDWORKS will do is it'll say, hey, look for a sketch. So I selected sketch 16, and everywhere that it sees a point, or also some people call it a node, but in SOLIDWORKS it's called a point, it will actually apply a hole there. And the reason why it's a hole is because I told this feature to reference cut extrude 1, which was this very first one. It's that simple hole. And so after I do that, you'll say, awesome. Now I needed to add one more hole to this point here. So that hole, I actually did a mirror, and what I did was I mirrored this feature about my right plane. Now, once again, I'm going through this and I'm saying I want SOLIDWORKS to model for me, and I want to base it all off of only a couple dimensions. And so once again, let's see what happens here. If I came in and I took this surface plane and I bumped this up to, let's say, 40. Updates, you'll see here that my segment tool works just fine. All my points stayed consistent. I made this line to where it came from that point over to this point, and that point is actually 4 inches in because that's based off of my original hole, which is also 4 inches in. Now to make this even a little more powerful, what I could do is come in here and see that cutout there, right? I gave it a 4-inch dimension. Here's how I can make this even a little more powerful. So if I double click on that, I'll say I want to make this equal to, if I click on this hole, or even just the sketch, let's say, and I click on that right there, SOLIDWORKS is going to make an equation for me. And so if I came in here and said, hey, I want to make that cutout there of 4, let's make it so that it's now going to be at 5. Push Control Q, you're going to see that it shrunk everything, or it made everything come in. That dimension of 4 is now going to be 5. It's driven off of 1 dimension. How I originally had it, if I came in and I updated that to, let's say, 5, this would still stay at 4. So now that I added that equation, once again, it's making it to where it will all be seamless and I only have to update 1 dimension instead of 2. So I wanted these holes to be centered about my display. So I'll simply come back to sketch 15 and we'll say, let's make this go back to 4, do a Control Q. Everything gets spaced out properly. Now, once again, I came in here and I updated sketch 1 to being 40 inches. So let's go back to 34, and I'll do a Control Q again. you'll see everything got resized for that 34 dimension. Once again, utilizing SOLIDWORKS to model for me, I'm not modeling for SOLIDWORKS. If I had 5 other dimensions on here, I'd have to go to each dimension and update each one. That is so time consuming and tedious. Nobody likes doing that. Instead, I just update one dimension, updates all the other ones. Super cool, right? Now after that, what I did was I made another plane, and what I wanted to do next was actually make the little spout that that will come out of the wall for your shower, and make it so it comes out of the side here. And I did a sweep thin on there and gave it a 1/2 inch ID, and I gave it a 1/8 inch thickness, so that way it comes out to 3/4 inch of a pipe. After that, if you look at one of our other videos here, I imported this body from my design tree. It's on one of our prior YouTube videos. Highly recommend you go check it out. It's importing parts into a part file, importing derived parts. And so I had this 1/2 inch MPT that I imported. Then I combined those two bodies. So this is actually all one item now. After that, I utilized the same sketch 16 that I originally had. I did another sketch-driven pattern. And so by utilizing the same sketch, if I update the sketch in any way, it's going to affect the sketch-driven pattern of the holes as well as these pipe fittings. Pretty cool. Then I also did a mirror after that. So now that's all done, let's hop on over to our assembly that I made for this. So my assembly, like I was saying, this is going to be utilized for displaying the shower heads, so that way at the bottom of the end cap, so imagine this being up here, all the shower heads are going to be down below. So looking at this, the consumer can look at the different shower heads that is provided by High Sierra Shower Heads and go, hey, those look pretty cool. We'll post up descriptions of each shower head here. And also the client wanted me to put High Sierra Shower Heads as their company name across this angled face here. So once again, I utilize this video to show you how we can utilize SOLIDWORKS to model for us. And once again, I did this as a live stream on Twitch, so you can actually go on to Twitch, see how we went about it. I'll post a link on this YouTube channel. These Twitch videos don't last forever. Unfortunately, after a while, they get removed. So you might, probably a year from now, you won't see that video anymore. So one other thing to look at on my assembly here before we close, I did what's known as a derived sketch pattern. So how does this work? Well, I'm going to use my rollback bar, and I'll just show you again really quick how to utilize this. So looking at this here, I want to come up here to my linear pattern, and what's really cool is that you could do a pattern-driven component. Pattern-driven component pattern. Yeah. So if we click on that, I select a component that I want, and what's really cool is that if you applied a pattern, such as a linear pattern, sketch-driven pattern, a mirror, if you applied those in a part file, SOLIDWORKS will actually recognize that in the assembly and will do another pattern to make it so where the assembly matches with it. So check this out. If I click on that, that was based off of a pattern that I did in my part, right? Because I did each of those pipes as parts, and I say okay to that. Do Control Q, and we'll see here, I'll pull that out a little bit, that it's done. Simply done. And let's say I want to mirror that over to the other side, which I did here on that very last one as well. Let SOLIDWORKS catch up with me for a second here. I got a lot of information going on here. If you didn't notice, on my shower heads themselves, they have knurls on them, and that is taking up a ton of processing resources. So my computer can handle it, thankfully. And so just really quick here, let's see what happens if I go back into my part file and say, oh man, we need to make this so it's larger, let's just say. And let's bump it up to, let's say, 48 inches, do Control Q. We'll see that everything got updated nicely. My points are still correctly spaced out. But let's go into my sketch 16, which is that sketch-driven pattern. I'm going to right-click on it, and on the relation, and I'm going to say edit segment points. And I'm going to bump this up to, let's say 4, let's say 5, and say OK to that. Now after I say OK to this, let's see what SOLIDWORKS does for me. It will go in and it will actually place in new holes and the little pipe fittings for each of those points. Pretty awesome, right? Now if I go back to my assembly, let's see what happens here. SOLIDWORKS will come in and will apply each of those components based off of my derived sketch, because derived off of a pattern on my part file. So once again, this is utilizing SOLIDWORKS to model for you. Don't go in and start putting in other dimensions and other relations and other rules, because when you start doing that, the more rules you apply and you have to go in and edit, the more likely you're going to forget one. And then with that, you'll start having complications within SOLIDWORKS, and you might miss a dimension that's pretty crucial, and you release the part, and now that part doesn't fit in your assembly. So utilizing SOLIDWORKS to model for you is extremely useful, and it's what SOLIDWORKS is meant to do. So utilize it. My name is Peter Estes, and I'm the owner of ValleyCAD. As I was saying earlier in this video, I did this whole part and assembly actually in a live Twitch video. So I highly recommend go hop on over to Twitch, find at ValleyCAD, like and subscribe to us on there. You will get notified every time we do a new stream, and on there you can ask us questions. That's what we actually did while we were designing this. Had a couple viewers on it, pretty exciting. Yeah, highly encourage you to do that. Also, a little bit of ValleyCAD here. Highly recommend you hop onto our website. We're www.valleycad.com, or you can just simply Google ValleyCAD and you'll be able to find us. We are a mechanical engineering and a product design firm. We also do 3D scanning, 3D printing. We also do CAD consulting like SOLIDWORKS training, AutoCAD training, draft site training. We also do training for 3D scanning, also 3D printing. So if you got questions on how to utilize software such as SOLIDWORKS, give us a call. I am always happy to answer questions on there and help out and see how we could utilize SOLIDWORKS to work best for your company or for your engineering team. So once again, thank you for watching this video. Please like, give us a thumbs up, and subscribe to this YouTube channel. Love making these videos, and hopefully they are helpful for you. Leave us comments. Have you found other ways to make SOLIDWORKS more streamlined for you? And like I was showing ways of using convert entities and how to place your planes so that we can use mirror functions and using sketch-driven patterns. Kind of showed a lot in this video actually. Hopefully it wasn't too much for you. So once again, thank you for watching this. Have a great rest of the day, and make sure you learn something new. See ya.